Now, if we move to the next level, van Hiele level 2, we can start analyzing the properties more deeply. For example, if we take a triangle here, we know from a zigzag or a saw that angle A is equal to angle D, that we spoke about just before in the previous slide. And angle B is equal to angle E from a ladder. But we see that the angles CDE lie on a straight line. Therefore, the angles A, B, and C of a triangle add up to 180 degrees. But notice the richness and the power of a tessellation, because students can now see the same applies here. Angle A is equal to angle D, because that is also a saw. Angle E is equal to angle B, because we also have a saw there. And clearly angle E, C, and D also lie in a straight line. And here we have another triangle for which A plus B plus C form a straight line. So here we are now working at van Hiele level 2, which is exploring the properties of a tessellation more deeply. And perhaps I should emphasize that one should not restrict oneself to triangles. One should work with different quadrilaterals. One should work with pentagons that tessellate. Yes, there are some pentagons that tessellate. There are not only regular hexagons that tessellate, but there are different kinds of hexagons that tessellate. And students should repeat the same activities and explore saws and ladders with them, and perhaps also other properties that I will not go in here. Here we have another example of a geometric theorem that is embedded in tessellations. We know that angle F is equal to angle H because it forms a saw. We know that angle G is equal to angle I because of a ladder in that direction. Therefore, we can see that this exterior angle, I plus H, is equal to F plus G, which is the sum of the opposite interior angles. A very well-known theorem in plane geometry. Here we have another illustration in a fairly standard representation. J is clearly the midpoint of this side of the triangle there, because this side of the triangle is equal to that side of this triangle. K also is the midpoint of this side of the triangle, because this triangle is congruent to that one. But we can see that JK is parallel to the side, but also JK is clearly equal to this length here and also to that, because these triangles are congruent. So therefore JK is parallel and equal to half of the base of the triangle, which gives us the classic, what we call the midpoint triangle theorem. So students can discover these. Of course, it is not proof, but they are already learning things at van Hiele level 2. Now, when we start dealing with van Hiele level 3, and I want to show the progression, how things that are discovered at the first level can gradually be formalized until it distills into a formal proof. For example, at van Hiele level 1, students may recognize parallelograms in this parallelogram tessellation. Here we have different shaped parallelograms. They are not similar. This one is longer than that one because its sides are double. They can also identify similar ones, but all at the visual level. At van Hiele level 2, we start analyzing the properties embedded in the tessellation more carefully. Students may notice, under the direction of the teacher very often, that this angle here is equal to that one because of a saw. This angle is equal to that one because of a ladder. And therefore, clearly we have these two angles equal because of the transitive property. The same thing applies here. This angle is equal to that one, and this one is equal to that one because of a ladder. Therefore, the opposite angles of a parallelogram are equal. And of course, from here, it is not difficult now for students to formalize it into a proof at level 3, where students can now see angle 1 is equal to angle 2 because of a saw. Comes now writing it down, formalizing it. Angle 1 is equal to angle 3 because of a ladder, and therefore, because of the transitive property, we have that the opposite angles are equal. Now, I want to move on to a very important point that is sometimes neglected, I think, in the Van Hiele theory, or perhaps not emphasized enough. It is very important that lower level activities, according to the Van Hiele theory, should provide appropriate conceptual substructures for the next levels. Teachers often encourage students to measure the angles of a triangle by hand and then have them add up the angles to have them discover that the sum of the angles of a triangle is equal to 180 degrees. Of course, if they do it by hand, there is a problem that very often the answers may vary from 175 degrees to maybe 185 degrees. If they use technology for measuring the angles, the answer will be precise. The problem, however, is that using technology, it will only show that the result is true, but it will not provide us with any explanation of why it is true. It will not provide an appropriate substructure for the eventual formal proof. And this, in the words of Brunner, measurement, and I'm not discouraging measurement, but measurement often does not provide an appropriate conceptual scaffold for the next level. Instead, I think we should look at an activity like this, and I have mentioned to this before. Translate a triangle by the vector AC, rotate triangle ABC around the midpoint of BC, so that students can see that this angle moves there, and now with a half turn, that angle actually moves here. And then to have students observe that these three angles always lie in a straight line like that, implies that because this angle is equal to that one and this angle is equal to that one, that the three angles of a triangle, because they are equal to those, always lie on a straight line, provides a better conceptual structure for the eventual proof that they will need to do at level 3. Because clearly this can be very easily formalized into a proof where we would start by drawing a line here parallel to that, and therefore we have that this angle is equal to that one by a saw, and this angle is equal to that one by a ladder. And I think the importance of the Van Hiele theory is to think carefully about the activities that we engage students in. It is not just about convincing them that something is true, but to provide them with a conceptual scaffold for them to reach the next level.